Hello, today's video is going to be focused on working with twin data, doing basic analyses with twin data, and visualizing twin data. This particular set of code does require some particular packages. I have included in your code lines that include install.packages so that you can go ahead and install those packages as a one-time event for use later on. You need only to uncomment out the line and run the line, and you will be able to have installed those packages onto your computer. If you've already installed those packages, you only need to call up your library function every time after the packages has been installed, and you can use that library um, for every future use when you have a new R session. So I like to put my libraries up on top at the beginning of a script. Other people do things differently, but these are the ones that we're going to be using today. And I'm going to go ahead and run those. You'll also note that I have also run my working directory. So you can go ahead and run your working directory as well. It looks like I'm actually going to have to install a package because it wasn't installed previously, and it looks like it's installed successfully. And I'm going to rerun that one package now. Okay. You'll notice that there is a warning message because this gplots package has been made with a more current version of R, and it doesn't exactly match my version of R, but this isn't going to ruin your experience. If you haven't done so already, go ahead and set your working directory. And now I'm going to be moving to line 36, where I open up an object or open up the data set, and the context of that data set will go into an object called twins. This /t indicates a tab separator instead of like a comma separator that you've seen previously. So that's how you would denote a tabbed separator. We have looked in previous videos on how to kind of understand what's happening in our data set. So you can learn a little bit more about your data set here. And as a reminder, we have about 2,400 rows or observations and about 31 variables or columns. When I take a look at the first 6 rows of this twins data set, this is the kind of data that are in this data set. And we can do a brief summary of our variables and have a sense of the variables themselves and a general understanding of how they're coded using the str function. If you wanted to take a look at the frequency tables, you could. One of the functions that I've used in the past is cross table, and you can use a Desker package to do that. I need to just check real quick. Yes, we have loaded Desker, so you are good to go. And then you can see in this data set, we have sex coded as 0 and 1, and the number of individuals in each of those categories. You can do the same for zygosity and various other variables. Now, we've talked a little bit about doing some graphics, but as a reminder, just wanted to talk to you a little bit about graphics and how you can do some for the purposes of visualizing twin-related data and also to save it. So right now I have this function that I've commented out that says PDF file equals classgraphs.pdf. If I were to run this line, what would happen is that every graph, every figure that I develop going forward would be going into this file. The only thing is that when that happens, we don't actually see it interactively inside of R. So it's going straight to the PDF, but you don't actually see that it's happening. So I typically suggest that you run your code to develop your figures first interactively in R. And once you're ready to share those figures, that you invoke a line like this one, and then they'll all get saved to this one file. So just to give this a try first interactively, we're going to run line 58, which is asking us to do a histogram on this one variable called VA_con, and it's going to produce bars in the histogram that will have a gray color. And I'm going to increase the size of my histogram so that you can take a look here. And that's basically what you're seeing is um, a variable with a normal distribution, more or less. Now, right now, we're seeing this image as a sole image, meaning that it's not sharing space with any other images. But let's say you have many images of a similar type, and you don't necessarily want each image to take up a single page. Maybe you want to see many of them at the same time. You can do that by using code that we have here. And by first saying, I want to change the parameters of what this image area is going to look like. Currently, it is viewed as a matrix of one row and one column. That's what you're seeing in this current image. But you can expand this so that you can show pictures of 3 rows and 3 columns and see many figures at the same time. So that's what I'm going to do here on line 61. And you don't see anything because all you're doing is changing the environment in which the images will be viewed. But then the next time you run an image, you start seeing some differences. In this script that I have here, what I'm doing is I am asking to see the histograms of several variables that are located inside of the twins object. And so I'm going to just put names of twins. And I can see then that variable number 6 is age, and then variable number 8 is VA_con, and then variable number 11 is VA_con, and variable number 14 VB_con, etc., etc. So we're going to go through and visualize all of these at the same time. And also on each one, we're going to put a small title on top so we can tell the difference between each one. So main equals blah, 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 all this is referring to the exact title that we want. And basically what we're doing here is we're pasting a lot of text together. So if you wanted to, you could see, and it'll probably give you an error, but you can try it out. Again, I'm always a big proponent of taking things little by little if you're trying to understand what's happening there, and see what comes of it. So what you can see is that it's pasting the text histogram of something here that we don't have right now. And Zy2, it's just the names of the ith variable that it's putting in there, and it's separating with a space. So now that's what the title for each one of them should look like. As you've seen before, the color of the bars in the histogram will be gray. And we'll also paste a title underneath each x-axis to be the mean of the variable name that is associated with that column number. And then we will also round that value to be 2 decimal places long. And we'll also add a density plot, a density curve with that histogram. So let's just select lines 62 through 69, and you got to go that far because we've got a squiggly bar, a squiggly bracket at the top and a squiggly bracket at the bottom, meaning that is the beginning and the end of doing everything inside of this loop here to go multiple times over. So I'm going to just run that. And if you look at your figure now, remembering that we changed the view from a 1 to 1 to now being a 3 and 3 rows and 3 columns view. And we have each one of the variables, the name that we're saying it's a histogram and the name of each of the variables. And we've also put as the x-axis the mean for each of the variables underneath that, that histogram. So that's basically what has come out of this. And it's a nice, quick way of being able to visualize and get a sense of what you should be expecting from your variables and further data analysis going down the road. Okay. Another way that people love to develop their nose for their data is to look at QQ plots. And so we're going to do a very similar approach for the variables that we just looked at. And instead of histograms, now we're going to look at QQ plots. And so you see here that we use that same for loop to call up each individual variable by number rather than by name. And that number gets substituted into wherever it sees an I, and it will run the function for that particular variable and doing it by the number. And so in this case, it's going to do QQ norm, and it's going to also add in a main title as well as a title under the x-axis to go along with each specific variable. So if you want to highlight line 71 to 75 and run, you can now see that we have a QQ plot for each one of those variables, and you can get a sense of what's happening there. If you wanted to make this space bigger so you can see it, you can certainly do so. And get a better sense of what's going on. Okay. Box plots are also a really nice way to visualize continuous data and are a very popular way to do so. So I wanted to show you about box plots so that you have a sense of how to make them and what goes into them. So box plots are just a simple function that is then calling a particular variable. And in this case, we're actually asking R to do a box plot by sex. So I want to see a box plot for males and I want to see a box plot for females. And I would like for the colors of each of those box plots to be gray. So if we go ahead and run line 78, you can see that you have a box plot for sex of 0 and one for sex of 1. Notice that we are still in our view where we have made the view of 3 rows and 3 columns. So now that we're putting new plots together that are kind of separate, it will slowly build and add on to the look. So now I'm going to run the box plot of VA-Con by zygosity. And you can see here now it's building up zygosity 1 box plot and zygosity 2 box plot. Now, I'm going to erase these two in the interest of, I'm actually going to erase all my plots. So I'm going to use my little broom up here in my plots viewer so that we can keep the view clear and simple. Cool. And now we're going back to that same set of continuous variables we did before, and we're going to go through all of them again, and we're going to run box plots by zygosity for all of these variables so we can quickly get through these visualizations and develop our nose for what's happening with these data. And it looks like I have taken out my rules for the viewer, so I'm going to just put those back up real quick. And actually, so that you can see, I'm actually taking this left arrow. You can see all your previous plots that you've done in a session by just arrow to the left or arrow to the right. So these were all of the images that we did for this work. And so you can scroll through and see everything you've done there. But sometimes it's a little easier to do all of them at the same time. So I'm rerunning line 61. And then I'm going to run lines 81 to 85. And now I have 3 by 3 matrix view of all my box plots by zygosity groups for these variables. Now, remember when I said initially that if you wanted to send your figures out to a PDF file, you basically will put a dev dot on, or in this case, a PDF function, name the file that you want your figures to go to, let's say, in this case, classgraphs.pdf. And then when you're done sending everything out, then you will just run a function. The statement says dev.off. So for the purposes of showing you this whole process, I'm going to rerun what we just ran. And I'm also going to clear all my plots one more time so that we can see that there's not going to be any add-ons. And I'm also going to add dev.off. And now I'm going to run all the way from lines 55 up to line 93. Okay, so you saw that no figures have been added to this window here because they're all going to the file. And also to convince myself and yourself that this is actually happening, I am going to now look at my file, my folder where this should be added. So now what you can see is I've got my folder where my working directory is, and I am just going to double click on this PDF file, and what you can see here is all of the images that we produced from that set of script. And now, because it's also off, we will not be moving those any more figures over there. All right. So now we've talked about visualizing data and have a couple of cues on how we visualize data. But it's probably also really helpful to think about how we work through and kind of manage twin data because there are some inherently different things when we're trying to merge and work with twin data. I'm going to show you a couple of different steps by which to work with these kinds of data. Um, all of them are good. There's some people will find some approaches easier and other people will find other approaches easier. So I'm giving you multiple steps and multiple options so you can also understand how this works. So first, we're going to break this down into a step-by-step situation where in this first instance, we're going to take a data set where you have all the twins, and each line, each row of that data set consists of the data of that individual twin. So twin one and all of their data, and then on the next line, twin two and all of their data. When you have data like this, we call it long data. But if you need to merge twin pairs, by a complete row, what you'll need to do is merge them by a family ID, a common family ID. And what we would typically do to make this happen, if we were kind of thinking in old school days where we have to do this all by hand, is we would make an object that contains all of the data from twin one. In this case, we're putting all of the twin one data in an object called dat A. And then you would take all the data from twin two into an object called dat B. Then what you do is you merge dat A data and dat B data by a variable called FAMID, which represents a common family ID number that would be shared between two members of that of a twin pair. And we also say that we want everything to be merged together, and that we want to distinguish whether or not a data set is coming from the first data set, in this case X, or from twin one, and those from twin two, so that we know whether or not the data are twin one's data or twin two's data. And we will denote whether or not data are coming from twin one by adding a suffix to the end of the variable to be underscore twin one and underscore twin two to denote for twin two data. The other thing that we're going to do, and that's what's happening in lines 120 and 121, is that sometimes, when we're doing these merges, we don't need all of the data that are produced, so we will delete them. The term null is what is meant by go ahead and remove that variable. That's one way to remove a variable if you really want to kind of hard code it that way. So let's go ahead and, do that all the way up to there. You probably won't see anything. So I'm going to run lines 104 to 107. And what we can do is just do a check to see if we're happy with how things have worked. We will do a dim of twins. And now we're going to do a dim of dat A. Presumably, dat A, the number of rows for dat A, should be half that of twins, the object twins. And in fact, we do have half. You could do the same for dat B, and yes, it's half that of the twins data, the twins object. Now, when we merge dat A and dat B, they are going to be sent into a new object called big dat, and they should contain both of the data sets from both of the twins. So again, as a quick check, I'm going to go down to my console and I'm going to run a quick names on dat A. Okay, and we said there were 1,200 people and 31 variables. And now I'm going to run a names on dat. What you can see now is that the number of variables here has increased or doubled, just about doubled. There's some overlap because of course FAMID is common between the two. And now you can see that we can distinguish whether or not the variables are twin 1 variables or they are twin 2 variables. Also, when we do a dim on dat to check the dimensions of that object, we see that there are 1,200 rows and 61 columns or 61 variables. So that's one way to do it. And we'll also take out twin ID because it's unnecessary to have twin ID now. And we'll do a dim on dat. Now we previously had 61 variables. Now we have 59. We took away 2. Everything's looking pretty good. And now we are also doing some recategorization of the variable zig5 because it doesn't really mean much to have a zygosity that is specific for twin 1 and a zygosity that is specific for twin 2 when both twins share the same zygosity. It certainly could be the case that we could have included zygosity as a by term in our merge statement, but in order to just keep things a bit straightforward, I wanted to not put it in there and then just take it out as a second step. So we will run this. And if you check the dim of dat here, you are increasing by 1. And we're reorganizing zig2 in a similar way. And then we're just putting a variable, a name called zig6. So what are we doing here? We're making a new variable that's called zig6. And this name will be entered here. It will be seen by R here, 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 and here. And it will then just put in zig6 in each one of these places. And it will then give the zygosity that would be common to both twins here and ensure that both twins have a zygosity. So we'll run lines 133 to 136. And we'll just do a real quick head on dat so that we can see what's happening here. So far, it looks like we've got everything in order. And then we're just going to remove some of these repeated zygosity variables that we had before. And that would be the end of our new data set. Now that was a lot of steps, and I wanted to walk you through so you understand kind of what goes into, generally what goes into developing data sets. But after a while, if you're merging lots of data sets and from different data sets often, this might get to be a pain. So it might be more advantageous to package all of those steps together into a function. and you're very familiar with functions because you've been using a lot of them up to this point, things like cross table or hist. We used hist to make those histograms, um, all kinds of functions. So this is an opportunity for you to personalize a function for something that you're doing over and over again and potentially save you some time going forward. So basically, all of the steps that we just identified in the previous set of code, we are now putting them all together and we're making them the statements more generic for any situation. And then you would just substitute out your specific variable names or data set names for your situation. So, for example, what we're doing is we're making a function that's called twindat. And that function twindat is going to ask for several things from you. Um, the name of the object that you want to go after, in this case, is called dat. That would be the data set that you want to work with. You have to have a family ID that is common where you're going to have a merge. And then the variable for which you might have twin ID to know who's twin, how are you designating twin one and how are you designating twin two. And then any zygosity variables that you may need that you might have to do additional merging or defining. So very similar to what we've done before, but now we're making all of these as more generic pieces that you can use over and over again. And up until this point, you're just saying this is what's going to go into the function. These are important things that we're going to have to define, but the actual function begins at the beginning of the curly bracket. Everything out underneath here are all of the steps that we had already done for previously, but we're just making generic. The other thing that's super important is that you have to return an object to actually work with at the end of the function. So that will be your updated data set. And then you have to remember to close your bracket to let R know that your function is complete. But these steps should look very familiar because we did them before with our data set, but we just did them step by step and we use specific variable names. But in this case, now we're making it more generic. So I'm going to run the function and then we'll see how the function works. So at this point, from lines 150 down to 178, all we're doing is defining the function. We're not actually doing anything with the function at this point. Go ahead and run that and you see it ran. You don't see anything that says, oh, I did a thing or whatnot. By the time you get to line 181, this is when you actually use the function for your specific situation. So in this case, we're making an object that's called twins2. It's going to use the function that we just developed called twindat. And twindat is going to use an object that we call, that is called twins. And in twins, we have specific variable names called FAMID, TWID, ZIG2, ZIG5, and ZIG6. You will need to know those variable names up front, and you'll need to substitute those out for your specific situation. And then when you run this, it basically says, aha, I'm going to use the function that you defined for me, and I'm going to go ahead and make a twin data set. So we'll run that. And it's there. And if you look at the dim of twins2, ho, 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 it is the same as what you had before, 1,200 rows and 56 columns. So very similar to what you had before. Now, if you're not for writing functions and honestly, a lot of times somebody's already thought of the thing that you want to do and you just need to find the right function. There is a function out there that's called reshape, and it really pretty much does all the work for you. Reshape was originally developed for longitudinal data. And so you'll see that some of these features inside of the function kind of refer to things that are time related, but you can just translate that for the twin situation and it works just fine. And in this case too, it allows you to determine how you want your output to be. In this case, we do want it wide because we want all of the twin one data in a set of columns and then all of the twin two data in another set of columns. So now we're making wide data. So this is a really super easy function, takes out all that work and it makes it look like we've done nothing and it's super simple. But it's also important to understand where these things come from. So now you know. In terms of once you have an object that you're happy with, that you've done all the work with, you may want to write that object out as a data set to use in other applications. Maybe you want to run it with another script that you've put together or whatnot. And so right here, we are doing what's called a write.table, and we are saying we're going to take the object that we just made, twins2a, and we are going to write all of the information from that object into a file called twins2a.csv. We will not have any row names, but we will have column names or column headers. And we will make a separator as comma delimited. And you can choose what you want. I just prefer to have comma delimited, but you can choose whatever delimiter you prefer with the write.tables function. It's very generic, and so you can choose whatever. I'm just going to run those. And now we have that table there. And to confirm that it's there, I'm going to show you my file, my window, and you can see now that I have a new file, twins2a.csv, that contains this file now that we've just generated. Okay, so now you've done histograms and all kinds of figures to kind of get a sense of what the data look like. You've now gotten your data ready for analysis with for twin types of analyses, and you've been able to pass your data into a file that you could use later. So there are many ways to start working with twin data, and similar to what we've been doing before, you can use our typical functions of dim, names, and head. But the other thing that I want to bring to your attention is sometimes you want to look at twin data sets specifically for each zygosity group. So a function like subset is really helpful. Subset says basically, I'd like for you to filter my data set based off of a criteria. In this case, I'd like for you to subset the object twins2 that contains all the twins, and I want you to only give me those twins for whom the zygosity is equal to 1. And I want you to take all this and I want you to pass it to an object called MZ. We'll do the same thing for this object called DZ. All right, we'll run lines 207 and 208, and we've made 2 new objects. And now we're just going to run a scatter plot of twin relationships so we can see what do these twin data sets look like in terms of the relationships between twin 1 versus twin 2 for these particular variables. So we're going to make sure that our view is on 1 and 1, so 1 row and 1 column, and then we're just going to run a plot. This is a scatter plot of twin 1 distributions of all the variables against twin 2 for this variable called VA con. And we're just making our colors black. And then same thing for the DZ twins. And so now you can see that you have DZ twins, and we will do a plot of age for twin 1 and twin 2 just to make sure that our ages are the same for twin 1 and twin 2, and also for DZ twins. And mercifully, no twins have different ages, so that's great. You can always also add things like Lewis curves to figures, so that's just letting you know that that can happen. And the other thing that's super helpful is being able to visualize correlations for MZ and DZ twins. So we're going to take a look at that now, and we're going to take a couple of steps to do this. So we're going to first generate correlations for MZ and DZ twins here on lines 228 and 229. And we've got those values. And if you want to see those values, RMZ, we have an object called RMZ. And that value is 0.7. And then we can also see a value called RDZ. And that value is 0.5. Okay, so we have these two numbers, 0.7 and 0.5, and we can actually combine them together. And so we're going to combine the numbers 0.7 and 0.5 together into an object called core2. And when we run those take a look at core2, you can see the two values, fantastic. And then we can actually also write the results out to another file called cores.csv. And we can also set up the background to be a white color. And similar to how we set up the view previously for a 3x3 look or a 1x1, now we can also set up the colors to be specific to whatever we'd like. In this sense, I'm going to go with white, but we could have chosen any other color. And then we can just make a bar plot of the two correlations, 0.7, 0.9. I've only changed the colors a little bit to this kind of cyan color, and I've also put a range for the y-axis as well as the x-axis, and just put some space between the two. So that's what's happening here. And with that, we have pretty much kind of gotten a sense of what kind of data we would be looking at using some of the basics of R, and kind of gotten our expectations ready for doing data analysis related to twins or other related family members. All of these kinds of tricks can be used in other settings. And so I welcome you to use those tricks in other settings. And as always, if you have questions, please just give a shout, send an email, and I'd be happy to answer them. Thanks so much.